Hi everyone. So the topic for today is blood grouping, okay, and we'll be discussing about the ABO blood grouping system and also about the RH blood grouping. So let me just check if this is live here. Okay, all right. Yes. Okay, so before I start, let me introduce myself. I'm Vani Kari, biology educator at Unacademy. I'm an engineer with bachelor's and master's degree in biotechnology and a B.Ed degree. Also a founder of a startup where I grow microgreens by vertical farming technology. Okay, so 1 second. So I'll just look at this one. All right. So the topic that I'm going to cover today under this blood grouping system, so I'll be covering the introduction part, okay. So like what exactly are the antigens, the antibodies, so we will study about that. And other than that, let's have a look at the ABO grouping as well. So then what is RH grouping, and erythroblastosis fetalis is basically, so there is something which is mentioned in your selena, okay. So that is specifically, what happens if the blood group, so that is the RH factor specifically. So if this RH factor of a mother is negative and the child is positive, so there are certain associated conditions which needs to be taken care of, so that I'll be addressing here in this particular session, okay. So that is erythroblastosis fetalis. So let's have a look at what exactly is this blood grouping system. So you know the blood of humans differ in many aspects, right? So you can see there is A positive blood, so there is B positive, AB positive, O positive, then negative category where the RH is not there, so that we call as negative. So there is A negative blood, B negative, AB negative and RH negative, right? Yes, so blood has been grouped using various systems, okay. So there are two types of widely used blood groups. So the one that we are going to study, so these are widely used. So we use this as the RH when we mention. So if the RH antigen is present, so we call that as a positive, okay. And if the RH antigen is not there, so we call it as a negative. So now ABO blood group, you know, and with that we also call it as positive and negative. So that depends on the RH presence or absence, okay. So now here let's have a look at the what is exactly the antigen or the antibody here, okay. So you can find antigen, so there is a particular chemical that cause immune response, okay. So what exactly immune response when we mention, and it is basically anything, okay, which can make or which can create the antibodies in your body. So it can be usually foreign object, okay. So the foreign object which is going to create the antibodies in your body, so that we call as the antigen. So now the chemical that is going to bring about the immune response, so that we call as antigen, and these antibodies are basically produced by you, okay. So that is produced by your body against the antigens that have entered, so produced in response to the antigen, so you can find antibodies there, all right. So two surface antigens on the red blood cells, so you can find A type of antigen as well as B type of antigen. So then the plasma contains two natural antibodies, so you can find two antibodies there, okay. And this is going to vary depending on a person, okay. So depending on their blood type, so you know there can be either one antibody, both the antibodies can be there, okay. So we'll have a look at this. So presence or absence of A and B determines the blood group. So let me just let's leave all that. So we'll have a look at what exactly would be the condition if there is a blood group A. Okay, so let me just explain you this. Okay, 1 second. Let's take blood group A. Okay, so now this is in case of blood group A. Okay, so what happens in blood group A? All right, so we are not talking about negative or positive here, so we are just talking about the blood grouping system. Okay, so now let's imagine, so there is a person, okay, and this person is having a blood group. So that means what? So we will be talking about the RBC, okay, and we'll also talk about the plasma that is there. So plasma is basically a straw colored fluid that you can find, right? And RBC is what? RBC is basically red in color. So that is because of the presence of hemoglobin. Alright, so now let's have a look at the RBC of an individual. Okay, the person who is having the A blood group. So this is the RBC, and on the surface of RBC you can find A type of antigen. Okay, so we will just draw here. So let's imagine this is the structure of A type of antigen. Okay, so this is what? This is A type of antigen that you can find. Okay, so now let me just label this. So this is A antigen, right? So in plasma what will be there? Any idea? Anybody can tell me what exactly will be there in the plasma? So what do you find in plasma? Okay, so in plasma you can find there is a antibody, okay, and this antibody which is there in the plasma, so this antibody is basically antibody B. Okay, so you can find anti-B antibody. So that is mainly because the structural variation. So let's say this is anti-B antibody structure. Okay, so this is the anti-B antibody structure now. So in this case, what would be the condition? So there is no perfect binding because this is square in nature, okay, and this is somewhat triangular in nature. So that means what? They cannot perfectly bind. Okay, so this is a perfect binding. So when we mention here, what is happening? There is a structural variation, so there is no perfect binding. So when there is no perfect binding, so there is no antigen antibody reaction. Okay, so when there is no antigen antibody reaction, so there is no destruction. So what happens instead of antibody B, that is anti-B, which is present in the plasma of blood group A person, so instead of B, if there was A itself, okay, so then antibody A structure I'll just mention here. Why is it I cannot see? Okay, yeah, cursor is anyway here. Okay, so now if I have to show you the structure of antibody A, so let's imagine this is the structure of antibody A. Okay, so if this is the structure of antibody A, so you can know that there is gonna be a perfect binding which can occur. So the antigen and the antibody can bind perfectly, which leads to RBC destruction. Okay, so this RBC will be killed, and that's the reason the humans, when we mention, so they do not have the same type of antigen and antibody. So basically different one you will find, so that the antigen antibody reaction can lead to destruction of the RBC. So RBC destruction can be seen here if there is a perfect binding. So if there is perfect binding between antigen and antibody, so you can see basically the destruction of the RBC. Okay, and there is another group, so that is blood group B also we will see. Okay, so this is with respect to blood group B. So in case of blood group B, what would be the condition now? Let's say the blood group B is there. Okay, so in blood group B, okay, So let's say the RBC again. So we'll talk about the RBC. So RBC has got the antigen. So the antigen is basically B type of antigen. Okay. So this is B antigen that you can find. So this is what antigen it is. So this one is B antigen. Okay. So you can find on the surface of RBC, you can find a B type of antigen, and this is basically on RBC. So if we are talking about the plasma, so in plasma what can you find? In plasma you can find the opposite one, so the one which is not there. So here it is the antibody which is there in the plasma. So this antibody would be, so antibody A, okay, because you know the structure of antibody A already, okay, which is somewhat again spherical, we can mention. Yeah, so it is somewhat spherical if we mention. So you can find it to be having a specific structure. So let's say this is the antibody A structure. So now since the antibody B structure is like this, so there is going to be perfect binding which can occur between a square and a square. But if this structural variation is there, so there's no perfect binding, okay, and that's the reason. So whenever we are considering these antigen antibody reaction, so if they are binding specifically with each other, so then there is a case that, you know, one second. So then it will lead to destruction of RBC. So now here anti-A is there. So there is no perfect binding between the antibody and the antigen. So let's have a look at the blood group AB. So same way in this case also. So in case of blood group AB, okay. So antibody we will talk of, okay. So what antibody you can find in blood group AB. So we are talking about blood group AB now, okay. So any idea what type of antibodies might be there? Okay, let's talk about the RBC first. So on the RBC you can find A type of antigen as well as B type antigen. So there is A, there is B. So basically you can find both the type of antigens here. So there is A type antigen you can find, and there is B type antigen that you can find. So AB antigen, so the antigen when we mention, so you can find there are A type antigen as well as B type. But if we are considering about the antibody, so you can find anti-A, okay, and there is anti-B. So this one is anti-B. So you can find both the type of antibodies, right? So anti-A is also there, anti-B is also there. So these are the antibodies that you can find in here, okay. So any doubt in this part, any of you? So this is with respect to antibody A. So now here no anti-A. So it is basically no anti-A and no anti-B. So that is because, let me just explain you this. So what will happen? So this is the structure of anti-A. So this is the structure of anti-B. So if these are there, so there are no, okay. So there are no antibodies. So there do not exist any antibodies because if there is anti-A, so let's say it is going to bind here, okay. So there is a perfect binding. Hi Richa, good evening. And there is going to be a perfect binding here as well. So if they can bind perfectly with each other, so in that case, whenever there is an antigen and antibody reaction, so it will lead to destruction of the RBC. And that's the reason those who are having blood group AB, so they will have both the antigens on the surface of RBC, that is A type antigen as well as B type antigen, but in the plasma, so there is no antibody, okay. So in plasma there is no antibody. So that is mentioned here. So as mentioned, so you can only find two surface antigens on the RBC. So one is A type antigen or B type. So even we have blood group AB, okay, so then there is blood group O. So in blood group O there is no antigen at all. So let me just discuss that as well, okay. So I'll just discuss it here itself about the blood group O, okay. So let's say blood group O is there, okay. So this is, we are going to talk about the blood group O now. Okay, it's Gauri here. Hi Gauri. Okay, so this one blood group O, when we mention, so in case of blood group O, what is the condition is, so let's say there is a RBC, okay, and we know that the antigen is present on the RBC itself. So now this is the RBC, and since we call this as a blood group O, so there are no surface antigen here. So like you saw in the previous one, so that is blood group AB. So on RBC there was A type antigen as well as B type was there. But when we consider about the blood group O, so there are no antigens on the surface. So no antigens are there. So there is neither A nor B. So in the plasma, if we have to consider, so in plasma what do you find? Since both the antigens are not there, so you can find antibody A, okay. So there is antibody A as well as there is antibody B. So you can find both the type of antibodies in blood group O, okay. So that is because, so if the antigens also exist and the antibody also exist, so there is a antigen antibody reaction. So there is a perfect binding which will occur, so that will lead to destruction. And here in this case there are no antigens, only antibodies are there, so there is no destruction of RBC, okay. So let's have a look at this. The blood group of recipient, so this needs to match. So whenever we are transferring the blood, so blood group of the donor and the recipient has to match, then only the transfusion is done. So if they are not matching, so what will happen? So basically, let's say there is a person, so this person is A blood group person and the other person is B blood group person. So if we are transferring the blood from this A person to B person, okay, so what will happen? There are antibodies, there are different antigen, so total destruction of RBC you can see with respect to the transferred blood. So that is because antigen and antibody reaction can occur, so which can lead to anemia or it can even lead to jaundice condition. So that is because since the breakdown of so many RBC is occurring, so there is a bile pigment which is produced. So if there is too much of bile that is being produced, so that means there is a breakdown of the RBC which can be seen. So if the RBC hemoglobin breaks down, so there is too much of bilirubin bile pigment, so that can even lead to jaundice, or otherwise it can be anemia. And that's the reason always a matching has to be done between the recipient and the donor. So now as mentioned here, AB is universal acceptor, okay. So that is because there are no antibodies in the plasma of the AB, okay. So then universal donor, when we mention, so this can donate a blood to every other group. So that is because there are no surface antigens on the surface of RBC in case of a O blood group. Just a second, let me drink some water. Okay, so now this is A blood group, okay. So this we already discussed. So there is antibody B, so A type of antigen you can find. In case of blood group B, so you can find antibody A, so B antigen you can find, so blood group AB, so there are no antibodies, both A and B antigens you can find. Then O, when we mention, so you can find both the antibodies but there are no antigens here, okay. So moving on to RH blood grouping, so this is, when we see, we just discussed about ABO blood grouping, so that is A blood group, B blood group, AB blood group and O blood group. So we just saw that, okay. So RH we did not mention anything. So when we mention RH, so this is going to indicate the positive or the negative that we talk of, okay. So we say there is A positive blood group, A negative blood group. One second. Okay, so there is A positive blood group and A negative blood group, what we say. Okay, so in that case, this is basically, we call it positive. So if the RH antigen is present, okay, and if the RH antigen is absent, so we call it as a negative there. Okay, so now RH antigen is present, so this is present on RBC surface, so that is in 80% of humans. Okay, so the ones who are having this RH antigen, so those are basically the positive individuals, and those who do not have this RH antigen, so those are considered as the negative individuals. Okay, so similar to RH antigen, which you can find in the rhesus monkeys. Okay, so the same type of antigen was found in the rhesus monkey, and that's the reason, so this can also be called as the RH antigen. Okay, so individuals with RH antigen, so them we call as RH positive. Okay, and the individuals without the RH antigen, so them we call as RH negative. So antibodies against the RH antigen are formed in the RH person when transfused with the RH positive blood. So let's see what exactly is the meaning of that. So now so let's imagine this is the RBC. Okay, so this one is RBC, and on the surface of RBC, let's talk about the AB positive blood group. Okay, so that means what? There is A antigen, B antigen. So this is A antigen, now this is B antigen. You can also find RH type of antigen. Okay, so let's draw one more time. So this is A antigen, this is B antigen, then you can find RH antigen as well. So same way, there is A antigen, B antigen, RH antigen. So that is, what is the meaning of this? You can find all the different types of antigens on the surface. Okay, so now this is RBC. Okay, so on the surface of RBC you can find A antigen, B antigen, and the RH antigen. So that is when we call it as a AB positive. So if we are just looking at O positive, okay, so this is O positive blood group. So in case of O positive, so this is the RBC. So you can just find RH antigens which are present here on the surface. So if we are mentioning A positive, so in that case what would be the case? So A antigen is there, RH antigen, A antigen, RH antigen, A antigen, RH antigen. So basically depending on what type, whether this antigen is present, so this is called as a positive. So there is one condition, so this one I was trying to explain, that is antibodies against the RH antigen are formed in a RH negative person. So who is that RH negative person now? So in that case, the AB negative. Okay, so there is A negative, then there is B negative, there is O negative. So in all these cases, okay, so these are all the cases. So with respect to all these cases, these are the negative individual who can react to this positive antigen entering their body. So let's say there is a negative person, okay, that means A negative person. So this is the RBC, and he has got only the A type of antigen. Now this is A positive person. So in this case RBC has got what? A antigen, along with that RH antigen is present. Okay, so there is a RH antigen also which is present. So in such cases what would be the condition? So whenever this negative person receives the blood from positive person, so for the very first time this recipient, so let's say this is recipient, okay, and this is donor. Okay, so first time this individual, that is recipient, is getting exposed to a new type of antigen. Okay, so that means it is a foreign object itself. So this recipient is going to develop antibodies to kill these antigens. Okay, so there is a we can say there is a reaction which is going to occur between antigen and antibody, and that will lead to destruction of RBC, and that's the reason. So antibodies against Rh antigen are formed in Rh negative persons when it is transfused with the Rh positive blood. Okay. And there is one more thing which is mentioned, so that is about erythroblastosis fetalis. So this is the case of pregnancy. Okay, so during pregnancy, that is first pregnancy if we are considering, so there's no much of difficulty associated as such. Okay, so but certain precautions that has to be taken. So first pregnancy, so the mother is negative mother, so she is a Rh negative mother, but the child which is growing in her womb, so that is actually the positive one. Okay, so that is Rh positive fetus. So now what will happen? The blood separated by the placenta, so there is a blood which is going to be separated by the placenta, remove the chances of Rh antigen exposure, that is to the mother. Okay, so that means the mother will never come across this particular antigen, because the bloods are not in contact. So that is the blood from mother, the blood from the fetus are not in contact. Okay, so they are not at all in contact. So in that case you can find that as they are not at all in contact, so there is no mixing up of blood. So that is in the very initial stages of pregnancy. Okay, so blood is separated by placenta, but during the delivery what is going to happen? So there is a slight mixing up of blood you can find. So this Rh positive fetus, what is this? So that fetus blood will be exposed to the mother. So mother, it is gonna get mixed with the mother then. Okay, so that is mother's blood. Just a second. Okay, so it is going to get mixed with the mother's blood. So when that happens, so this mother will now develop antibodies against the Rh antigens from the child. Okay, so in that case what is going to happen? So when the antibodies from this mother are basically generated against this particular Rh antigen which is growing in the fetus of a mother, so during the second pregnancy, so there are consequences which has to be faced, but during the first pregnancy, so there are no associated risks. So what has to be done? So at the end of the, so let's say the same mother is getting pregnant, that is for the second time, so she needs to take care. Okay, so that is by killing all the generated antibodies well in advance before the delivery. Okay, and that is how the erythroblastosis, that is by the cells, by dying of the RBC cells in the fetus, so it can even lead to death of the fetus. So in order to avoid the death of the fetus, so basically during the first delivery what happened? So there was a mixing up of blood, no, and because of that there was an antibody development. So this antibody, if we kill, so that would be more than sufficient to have the next child. So there won't be any what we can say difficulties for the delivery as such. So in this case, so second pregnancy, the Rh antibodies from mother's blood can leak into Rh positive fetal blood and they can destroy the RBC, and we do not want that to occur. So this can be fatal to fetus. So the survival of this fetus can get affected. So it can also result in jaundice as well as anemia. So this is in a normal condition. So jaundice and anemia is also a possibility. So this can be avoided if anti-Rh antibodies administered to mother. So that is after the first delivery. Okay, so this can be avoided if anti-Rh antibodies. So what is that anti-Rh antibodies? That means there are certain antibodies which can kill these Rh antibodies that are generated, and once it is killed, so basically the child will be safer. That is the second child. So blood group AB, so it has got no antibody, right? So a person with blood group A requires blood. So the blood group which can be given is, so that is a person with blood group A. Okay, So that means we can give A blood group or the O blood group. So erythroblastoma fetalis is due to Rh incompatibility. Yes, that's true. Okay. Rh antigen is present on surface of what? It is present on surface of RBCs, right? Any of you, any doubts? All right, so we have come to the end of the session. Okay, so thank you. Also, see you all in the next session. So next session is on Friday. So same time, that is 4 p.m. Okay, so you all can basically click on this bell icon to get notified about the session. You can also subscribe to our new channel, so that is ICSE and ISC Masters. Like and share the video, and if you need this PDF, so you can just join my Telegram, Vani Kari ICSE class 9 and 10 biology. So search it on Telegram, so you'll find it, and you can join in there, so I can send a PDF there. Alright, so see you all in the next session, everyone. Bye bye. Thank you all.